In this video, we will discuss about generalized combination. The generalized combination illustrates in how many ways can choose R objects from a set of n objects with repetition allowed. To make us more familiar with generalized combination, let's consider this example. Assume that you need to choose 5 fruits from 3 of different types, which is orange, pineapple and apple. Theoretically, you may list down each and every combination. But, to list down all the combination is not efficient and confusing. To make this simple, let letter A, P, O to represent these 3 types of fruits, N would be the types of fruits to choose, while R be the combination of fruits being chosen. Assume that the first fruit being chosen is apple, and apple would still be the choices since the condition allowed repetition, and I would like to select pineapple as my second fruits, while number 3 for orange. And so on and so forth. For the last fruits being chosen, O is not repeated since we have done for our combination. So, as we can see, out of 7 objects, we choose 5, that is 7C5, so when you apply this formula or this from generalized combination, it will be exactly the same with this one.
Okay, let's look at the next question. From the question, we are going to pick 2 objects from 3 given choices of objects with repetition allowed. Since it is a combination with repetition, we cannot use the normal equation for combination calculation. Instead, we should use the equation given as shown. The 3 objects given are represented by A, B, and C. If the first object that we chose is A, then we have to replace A, because repetition is allowed. For the following object, we choose A again. The result shown is just like choosing 2 objects from 4 given objects, which fulfill the equation given. If we substitute the information given by the question, we could see that the result is same as the previous result. Therefore, we have to use this equation in combination with repetition.
Hello guys, let's look at the questions. Suppose that a cookie shop has 4 different kinds of cookies. How many different ways can 6 cookies be chosen? Now let us look at the solutions. The number of ways to choose 6 cookies is the number of 6 combinations R of a set with 4 elements N. By Theorem 2, the number of R combinations from a set with n elements when repetition of elements is allowed is n plus r minus 1 CR is equals to n plus r minus 1 C n minus 1. The calculation is 9C6 equals to 9C3 equals to 504 divided by 6, and the final answer is 84 ways to choose 6 cookies from the 4 kinds.
Let's look out generalized permutation. What is generalized permutation?
Generalized permutation. Generalized permutation is permutation of an object when some of the objects are indistinguishable.
Permutation without repeated letter. How many ways the words can be arranged of these words? A. Set. B. Matrices.
There are 3 letters in word set. The way can be arranged is 3 factorials. 3 factorials is equal 3 times 2 times 1 equal to 6 ways.
Matrices. They have 8 letters. 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equal to 40320 ways. Permutation with
repeated letter. How many ways of the words below can be arranged? A. Processors. B. Sequences. Formula of repeated permutation is n factorial divided by n1 factorial times n2 factorial times n3 factorial to nk factorial. N represent the number of objects, while n1, n2 and n3 is same type of each element.
A. Processors. This word has 10 letters. P has 1 letter, R has 2 letters, S 3, O 2, C 1, E 1. According to the formula, 10 factorial divided by 2 factorial times 3 factorial times 2 factorials equal to 151,200 ways.
B. Sequences. This word has 9 letters. S 2 letter, E 3 letter, Q 1, U 1, N 1, and the last one is C 1 letters. According to the formula, the answer should be 9 factorial divided by 2 factorial times 3 factorial. And the answer is 30240 ways.